This video is on trigonometric identities and how to use them to simplify expressions and for proof. So in your formula sheet you can find this trigonometric identities. So you have tan theta is exactly sine theta over cos theta, and sine squared theta plus cos squared theta is exactly 1. Now you need to be able to use these to simplify expressions like this. Now the way we do that, we use some algebraic manipulation here, and then we see what we can substitute using either one of these. Okay, so can we make a substitution to help us simplify these expressions? So I can see that if I write this sine squared theta as sine theta times sine theta, that might help me. So let's start by doing that. So I have sine theta times sine theta over tan theta times cos theta. Okay, now I can see that I have sine theta over cos theta, and I have that here as well. So I can substitute tan theta for this sine theta over cos theta. So I'm just going to write this out separately so you can see what I mean by that. Sine theta over tan theta times sine theta over cos theta. Okay, so this line is just the same as this line. Now I can see that this is just tan theta, so I'm going to write this as tan theta now. So I have sine theta over tan theta times tan theta. Okay, so now I can see that actually this simplifies with this. I can write this over 1, okay, and then it's easier to see that they simplify. Okay, so those ones simplify now, so I can cancel this with that, and I'm left with sine theta over 1, which is just equal to sine theta. Okay, so what we've done is we've used some algebra to separate this out like this, and then we made a substitution for this sine theta over cos theta using this identity here, and then we saw that this will cancel with that, and we're left with sine theta. So this simplifies to just sine theta. So let's have another question. So we have a proof question now. Now this question is really very similar to the one above. It's just that I need to show that this side looks like this side when it's simplified. Okay, so how does this side look like that side? Now again, we need to use some algebra to make this look a little bit like something I can substitute from here, and then we make a substitution and then we try and simplify. So let's do that. So I can see that cos theta factorizes from the denominator. One other thing, actually, we're going to work with only one side. Okay, we can't work with both sides, and it's always best to pick the side that looks more complicated and simplify it to make it look like the other side. Okay, so we're going to use this side. So we have left hand side is equal to sine cubed theta over, okay, so now I'm going to factorize cos theta from here. So I'm going to have cos theta, I'm going to have 1 minus cos squared theta here. Now I can see that this looks a little bit like this one. Okay, so I'm just going to work with this one and show that I can derive this from here. So let's do that. So I have sine squared theta plus cos squared theta is exactly 1. Now if I minus cos squared theta from both sides, I'm going to be left with sine squared theta is exactly 1 minus cos squared theta. Okay, so this is what I actually have here. So I can see that 1 minus cos squared theta is exactly sine squared theta. So I can actually substitute sine squared theta into here, and then that will simplify with that. So let's do that now. So we have sine cubed theta here over cos theta, and this 1 minus cos squared theta is just sine squared theta. So I'm just going to write that, sine squared theta. Now I can see that these will simplify, and to show that, I'm just going to write this as sine theta times sine squared theta. So let's do that. So we have sine theta times sine squared theta all over cos theta times sine squared theta. Okay, so now I can see that this will cancel with that, and I'm going to be left with sine theta over cos theta. So let's show that. So that will cancel with that, and then I'm left with sine theta. Go back to blue. So sine theta over cos theta, and I know that sine theta over cos theta is actually tan theta. So I can say that this is equal to tan theta. So this is equal to tan theta, and this is what we needed. We needed to show that this side actually equals to tan theta, and this is what we've done. Okay, now here are some questions for you to try. So these first questions, you need to simplify them using the identities, and here you need to prove that this side is exactly this side. Okay, so do those questions and then bring that to the lesson.